Hello and welcome back to Ganesh Institute. So in today's video, we are taking up Lagrange multipliers. These are used in optimization. So what is optimization? When you want to see what can give us a profit. What is the minimum or maximum value of a particular function? At what point we can have maximum cost, minimum loss, maximum profit, all those things, minimum, maximum, these are considered in optimization. Okay. So what does this Lagrange multiplier have? So you will be given with a function and you will be given with a constraint. So constraint like x is greater than 0 or less than or equal to 0, y is greater than or equal to 0, something like that, that this function in terms of x and y is defined when a certain condition or a set of conditions are being followed. Okay. So if there are sets and you have constraints, you have a function, you can consider the constant term as gxy. Okay. This will another thing. Now, what will happen? A new function you have to create. And for that, the condition would be you have to set the constraint 0. You have Lagrange multiplier, we denote it by lambda. We need to multiply it by lambda. And then this is the final product. The final result which you have to use. Now it sounds so theoretical, right? Let's try a question and then see what have we understood. So here the question is optimize this function, which is in the variables, which is having variables in terms of x and y. And the constraint is given that this is the condition. Okay. So your first thing is you need to create this function in such a manner that this is of the form xy, right? So you'll create a new function considering the old function which is given to you in terms of xy, plus you will put in the lambda, which is Lagrange multiplier, and you will put here the constraint. But in which form? Firstly, you will put constant and then the expression in terms of xy. So that means this is what? Constant is 56 here, and you bring this x plus y onto the other side by putting it 0, right? So this is your value which is going to be here, okay? If I distribute this minus, it will give you minus x minus y, right? So your new function is, this is z, 3xy plus 6y square, then plus lambda 56 minus x minus y, right? Now your step number 2 is partially differentiate. So you need to partially differentiate, and you know what does it mean by partially differentiate something. Partially differentiating something means if you are doing it with respect to x, consider y as constant. So this is your z, right? So if you are doing it with respect to x, then what it will be? 4 to the 8x plus derivative of 3x is 3, y is constant. This is completely 0 because it is only having y. Then this is constant, this is minus 1 and y is 0. So your zx has become 8x plus 3y minus lambda. Similarly, you get your function with respect to y, partially differentiated with respect to y. So this is gone because it is having x. So you are keeping it, considering it's constant. So differentiation is 0. Then with respect to y, it will be what? 3x, right? Yeah. And then this will be 6 times 2, 12y. And again, these two are constants, only minus lambda will be left. Right? And then third thing is you have to do it for lambda also. So for lambda, if you do, this one is not having any lambda. This is also not having lambda. So these are zeros. Only this one, coefficient. So if you are doing it with respect to lambda, so differentiation will give you 1 and this whole thing will be here. Okay. Now what you are supposed to do, you have to put all of them, all these partial derivatives as 0 in order to find out those critical points. Okay. And you solve it for x, y, and lambda. So what is it from here? This is minus, you can do, this is your first equation, second equation, third equation. So if you see this, let's get rid of lambda first. If I subtract first from second, what will I get? 3 minus 8 minus 5x, 12 minus 3, 9y, minus lambda plus lambda, 0. Right? So from here you can see 5x is 9y. So x becomes 9 by 5. 5 was a 5, 5 8s are 40. 1.8y, right? And then you can substitute in third one. So what you will get? 56 minus x, which is 1.8y minus y equals 0. So 1.8 and 1.8y equals minus 56. So y becomes how much? 28 result and 0.20. And then you substitute anywhere and get lambda. So from here lambda is 8x plus 3y, right? So 8 times x. X you've got 1.8 into 20. 36, right? So 36 plus 3y. 8 6 are 48, 8 3 are 24, 4 28, 3 2 are 6, 8, 14, 348, right? So once you've got everything, lambda, x, and y, just substitute in the new function, which is this one, right? And once you substitute that, you will get your function, which is the optimized function. So if I substitute 4x, that is 36 square, plus 3xy, 3xy is 20, plus 6, 20 square, plus lambda, which is 348, 56 minus x minus y, that is 36 minus 20, right? You can solve it and you will get 9744. So this is your optimized value. Whatever is asked, minimize or maximize value, you have to check. So this is how you can solve particular question related to Lagrange multiplier. Now this can have complex questions also. I'm bringing it in the next video. Till then, take care of yourself and don't forget to like, share and subscribe my channel. Bye bye.